Hello, today we're going to talk about experimental design. We're going to continue on. We ended in our last presentation where we talked about blocking. And so today we're going to thoroughly talk about how to describe an experiment in detail and in context. And we're also going to learn how to differentiate completely randomized versus block experiments. And then we're going to determine the appropriate blocking variables for given scenarios. So let's do some recap from what we had last time. Let's move my over here. So the first thing we talked about was that in order to have a well-designed experiment, you have to include comparison. It's the use of at least 2 treatment groups. You also have to have randomization, the use of chance to assign subjects units to treatments. You also have to have replication, meaning using multiple subjects in each treatment group, and if possible, repeating the experiment multiple times with different groups of subjects to avoid something just being a fluke versus being a true experiment. And then, of course, control, which makes conditions as similar as possible for all treatment groups. And usually when we're talking about comparison, it's usually a comparison to a control group. So, how do you explain or describe an experiment? Well, we're going to do, here's an experimental design essential. These are the things that are necessary when you are making an experimental design. Okay. First, you have to describe how you're going to randomly assign your subjects to the different treatment groups. Same as your simple random sample assessment, you have to basically be detailed about how you're going to do it. You have to explain what the treatments are, and you have to explain what the response variable, what is it that you're looking to measure or evaluate or compare at the end of the experiment. And then remember, you have to be specific. So you don't just say, I'm going to randomize and give one treatment one without explaining what treatment one is. I can't say that I'm going to compare the 2 treatments without saying what exactly it is that you're comparing. You have to be detailed, be specific. So here's an experiment that we're going to look at. Cell phone company is working on a new keyboard design, and they want to do an experiment testing whether the new keyboard results in customers typing faster. So they have 200 volunteers. They've been recruited to be part of the study. And so we're going to talk about explain how you would carry out a completely randomized experiment for the study in which exactly half of the volunteers are assigned to the new keyboard and the other half of the volunteers are assigned to a control group. Now remember, to be completely randomized, things like blocking, there's no blocking or grouping allowed because then it's no longer completely randomized. So first, we're going to do a little flow chart. I find that flow charts help you to be organized, okay? And just kind of gives you an idea, gives those of us looking to see what you're doing, but there is some details you have to give afterwards. So the first thing is you're going to say, I'm going to take my group of 200 volunteers and I'm going to randomly assign them into group 1 and group 2 of 100 volunteers. Now, once again, this is random assignment, and we'll go more into detail about what you have to do about that part. And then in each group, first group, I'm going to break them and give them treatment 1, and I have to be specific. I'm going to say that treatment 1 is going to type a specific paragraph using the new keyboard, and group 2 is going to get treatment 2, where they're going to type a specific paragraph using the old keyboard. And then last but not least, I'm going to compare the typing speeds or words per minute between the 2 keyboards. Now, notice that at the beginning I said random assignment. So it is important that once you've done this flowchart, you must later write out your randomization procedure separately, and you have to be specific. So let's talk about how we would do that, okay? You number the volunteers with a number from 1 to 200. Now, you have to be specific. Don't tell me you just number the volunteers. You're going to tell me exactly how you're numbering them. And then next, you're going to say, tell me how you're going to select from these numbers. You can use a random number generator. It's perfectly fine to use RNG on a calculator, or you can be doing it on a computer, and you're going to pick 100 random numbers. And once again, you have to tell me 100 random numbers from what range. You have to say from 1 to 200. And you also have to ignore any repeats, because remember, if you're using a random number generator and you're just randomly selecting numbers from 1 to 200, the number 1 could come up more than once. So you have to say ignore any repeats. And then you have to say what you're going to do with them. So I would say that the volunteers whose number are chosen will be placed in treatment group 1, and then the remaining volunteers will be placed in treatment group 2. Now, if you're not going to use a random number generator or a computer, you have the option where you can say, I'm going to number them on a slip of paper, okay? With a number from 1, I'm going to number the volunteers with a number from 1 to 200. I'm going to write the numbers onto slips of paper, and I'm going to put the slips of paper into a large hat. You have to make sure that you stir the slips, and then without looking, I'm going to select 100 unique numbers. And then just like up, you're going to tell me how you're going to assign them, and the volunteers whose number are chosen will be placed in treatment group 1, and then the remaining will be placed in treatment group 2. Okay? Whatever method you choose for your randomization, just make sure you're specific. Make sure if you're telling me you're numbering, tell me what you're numbering, what's the number range. When you're selecting them, make sure if you're using a random number generator, you say no repeats. Or if you're just pulling it out of a hat, make sure you're saying 100 unique numbers. Okay, so now let's talk about blocking. Okay, so what we just did was what we called a completely randomized experimental design. And remember, we said that didn't include any blocking. But let's say on this study, we thought that age of the volunteers might make a difference in how quickly they can type on a keyboard. Now, I can attest for that because I know that my son can type and text a whole lot faster than I can. But they also said that the scientist in charge of the study believes that male and females type equally quickly. So I have 2 things that I have to consider about blocking. So the question is, which variable, age, or gender do you think we should use for blocking? So, well, based on the fact that they say that they notice that older people don't type as fast as other younger people, that we will block by age. Okay, and why are we going to block by age? Because we're going to separate younger volunteers from older, but we're going to block it because it is thought that has an effect on typing speed. Now, in regards, blocking will help to control the effects of age on typing speed. So if we put the older groups all together, it minimizes that variable in the typing speed within each block. Now, we're not going to block by gender because the typing speed is thought to be equal for males and females. So there's no benefit in separating males and females before assigning treatments. Now, it's important when you decide you're going to block, you can't just tell me what you're going to block. You have to be specific as to why. Okay? So just like you're specific as to why you're taking a stratified random sample, it's similar reasoning. So you tell me you're blocking by age, you have to tell me why you're blocking by age. You also have to tell me you're not going to block by gender, and you have to tell me why you're not going to block by gender. So you have to always explain why. All right, so how do we describe a blocked experiment? Well, it's very similar to a completely randomization. It's a diagram that looks like that, except that you start with your blocking. So for here, we're going to take our group of 200 volunteers. And remember, we said age. So we're going to take and we wanted groups of 100. So we're going to block by age. We're going to take our 100 oldest volunteers and our 100 youngest volunteers. So now I have the 2 groups. I have blocked out age. So now the rest kind of becomes the same. I'm going to In my 100 oldest, I'm going to randomly assign 50 to one group and 50 to another group. And I'm going to do the same with the youngest group. I'm going to randomly assign 50 to one group and 50 to another group. And then I'm going to basically define what treatment am I going to assign to each group. So in my oldest, my first group is going to get the treatment 1, the new keyboard, and my second group is going to get treatment 2, the old keyboard. And the same thing with my youngest groups. Group 3 will be treatment 1, and group 4 will be treatment 2. Make sure you don't use, for 100 oldest, you say group 1, group 2, and then the 100 youngest say group 1 and group 2, because then it's confusing because we're not sure which group. So you give them a different number. And then, of course, we're going to compare typing speeds between the two keyboards for the 100 oldest groups. And we're going to compare typing speeds between the younger group and the two different keyboards. Now, you've made the flow chart, but just like before, when we say we're doing something random, we have to be specific about how we're going to do it. So you're going to have to tell me exactly how did you take your 100 oldest volunteers and break them up into two groups? Or how did you take your 100 youngest volunteers and break them up into two groups and decide which treatment? You have to be specific. That has to be included. Okay? Yes, you still need to describe the randomization process. So now we're going to talk about something referred to as extreme blocking. Okay? Remember that blocking means that we separate our subjects into groups and then run a separate experiment from each group. Okay? But remember, we do this because we want to minimize variation between treatment groups. Minimizing variation is always important in any type of randomization experiment. So let's say that we have a response variable that we feel has many possible confounding variables, and we want to control all of them. Let's just say that age is in here, and maybe we found that the type of phone you have could have effects, and maybe your gender does actually have an effect, and maybe how many text messages you send, meaning that the more text messages you send per day could affect how quickly you can type. And these are all things that we want to control, all of them. Okay, well, the thing is that instead of continually dividing our group of subjects into smaller and smaller groups based on all of these variables, we can use something called match pair blocking. With a match pair, we are dealing specifically with groups of two, and we do it in two possible ways. First one is we can pair up our subjects where the pairs are super similar. I mean, they could be the same age, they could be the same gender, they have the same type of phone. They basically type about the same amount or text about the same amount each day. So they have super, super similar. And then we randomly assign one of them to get one treatment and the other to get the other treatment. So one will get the old keyboard, the other would get the new keyboard. The other way that you can do it is that where you're still matching them, but then each subject gets both treatments. And I will randomize the order that they get it. So I may say this one's going to get this treatment first, and then they get the other one, and then the other one may get the other treatment first, but they both get both treatments. Okay. All right. So here's an example. And here's my subjects, and I'm going to match them up by the color of my smiley face and what kind of smiley face they have. So we're going to pair expand them units according to specific similar characteristics. And like I said, by color and by smile. And so I'm going to put them together, and then I'm going to randomly assign them to a treatment. Okay, so randomly assign one of each pair to one of the two treatments. And here I go. So now I have randomly assigned. And then I'm going to give the treatments, and then I'm going to compare. Now, you do have to explain your randomization for match pairs. And most of the time, we explain it by what we do is called flipping a coin. So assign each person in a pair to be heads or tails. All right. And then you're going to flip a coin for each pair, which is very important that you say that. And whichever side faces up, heads or tails, that person gets treatment A and the other person gets treatment B. Now, when you say you're going to assign each person to be heads or tails, you have to determine beforehand. It is important, just make sure you say you'll flip a coin for each pair. If you just do it once, then everybody doesn't have an equal and likely chance. So you have to flip a coin for each pair. You must give each person in each pair a fair chance of going either way. So that's all for today, and I shall see you next time.